are tables and views that provide us with data for planning and reporting. These infra providers are either real objects such as ADSOs or virtual providers such as composite providers. We will cover each of these objects that are relevant for planning in more detail later in this lecture. Data Store Objects Advanced or ADSO were introduced in BW 7.4 SP8. It is now the central data storage object in BW and combines the functions of the original DSO, PSA, InfoCube, and hybrid providers. The ADSO will play a central role in the development of our planning models. While a single infra provider will generally represent a type of activity, for example volumes planning, we will go a step further and create ADSOs by logical partition as well. It is good practice to have separate ADSOs that at a minimum separates plan data from actuals. The actual data may be stored in an application-specific ADSO, and we will connect that actual data with our planning-enabled ADSO under a single composite provider. With the creation of an ADSO, SAP provides templates which assists in the setting up of the ADSO according to its intended use. As we are mainly concerned with planning, we will focus on the ADSO that are relevant for planning. The planning ADSO is the central object we will use in planning. We will create the ADSO with the following properties. We will select the template to match planning on InfoCube-like object. The ADSO will behave like a cube with all characteristics as a key. This behavior is desired as we can create aggregation levels as a subset of all the characteristics in the ADSO. When an ADSO is created, several underlying tables are created and the tables vary according to the template. For the planning-enabled DSO, the following tables will be created. Since the ADSO is a flat structure, we can select directly from the table in SQL or ABAP when we write our AMDPs. But which table? The best table to select is the 7 table or view for reporting for data store. For example, we can write the following SQL. Let's demonstrate the code in Eclipse. So I can select from my ADSO tvol A20, select the 7 table and execute. You can see that the records are returned from the DSO. This includes the request number as well. The data returned will consist of all the data in the 1 inbound and 2 active tables. This read is also not subject to the BI analysis authorization checks and is very useful for referencing application-wide assumptions and rules. Alternatively, an external HANA view can also be created by selecting the relevant indicator. This will create a calculation view on HANA which can be selected from SQL using the following format. Let's look at it in Eclipse. If I look at my ADSO, the indicator external SAP HANA view is checked. And after executing the code for both these select statements, which is basically equivalent, you can see for the first statement, the data is returned. The second statement, the same data is returned. However, there are 1 or 2 differences. The first is the text is also returned, and the info objects have the 0 in front of it, while the select from the DSO, the 7 table, does not have the 0 in front of it. The path for the external HANA view, the system local BW, and so on, is configured in Transactions Pro. So let's go to Transactions Pro. It is done under SAP BW for HANA, under Data Modeling, and Settings for generating external SAP HANA view. Here we can see the path. There's also some settings for authorizations, and a very useful indicator is the division by 0. If a division by 0 is executed, the system will simply return a 0. In the Planning Workbench Transaction RS Plan, there are several settings relevant to the infra provider. These will be covered in more detail in later chapters, but let's review some of them. On the infra provider, this screen displays the characteristics and key figures in the infra provider. No settings or adjustment can be made here. Under Central Settings, we specify the key date, which is important when displaying and using time-dependent master data. The maximum number of combinations generated determines when combination generation terminates, and it is important when we artificially generate combination. It is infrequent that this number needs adjusting, but if we need to increase it, it has a significant performance impact. One setting we will customize later on is assigning a planning sequence that runs when we save data. The sequence will always run when data is saved to the info provider regardless of source. For example, regardless whether it's another planning sequence or a query. Characteristic relationships will be covered in its own lecture, but in short, it allows us to derive fields that are generally not in the aggregation level. And data slices allows us to lock data against changes and is very useful in controlling data during the planning cycle. Composite providers are virtual providers that combine several other info objects either by a join or union. For planning purposes, however, only composite providers that unions underlying info providers can be used. In the current version, you can only plan on a composite when the underlying ADSO is assigned directly to the composite provider. At the time of this lecture, if the ADSO is 2 levels down, planning cannot be performed. You will still be able to create the planning ready query, but as soon as values are saved, an error is issued. It is best practice to always allocate your ADSOs to a composite and create your aggregation levels, filters, and queries on the composite provider. This provides a significant amount of flexibility and agility to planning models, as new ADSOs can be allocated to the composite as required. For example, we can split an existing ADSO into logical partitions by company code, add a new ADSO for actuals and so on, with minimal changes to the aggregation levels, filters, and queries. When creating the composite, a mandatory technical info object, ZeroInfoProvider, is added to the composite. This enables us to control the source and target base info provider from which we read or write data to. As for ADSOs, we can also create an external handler view for the composite provider. We can add the info provider info object to determine the source of the data. Now let's look at the data selection from the composite in Eclipse. So I've got the 2 previous SQL statements for selection straight from the ADSOs and also via the external handler view for the ADSO, and now this additional line of instruction selecting from my composite TSL P10. So if I look at TSL P10, you can see that it's been marked as an external handler view. Going back to SQL, looking at the results of the execution, you can see that it returns the same results as the selection from the external handler view for the ADSO. It also returns the text fields as well as the info object with the 0 concatenated in front. Open ODS views are another type of base provider. It is also a virtual provider, and again, it is not represented by any underlying tables. The Open DSO view also differs from an ADSO in that we cannot plan to it, but it plays an important role in planning scenarios. The Open ODS view allows us to provide real-time information to our planning models. For example, we can base an Open ODS view on an ABAP CDS view, which in turn is based on a SAP transactional table such as ACDOC-A and so on. The underlying tables for an Open ODS view is the source table or the view itself. We cannot write a select on the Open ODS view or create an external handler view. However, it is possible to view the data using transaction list cube in BW4. An exception to this rule, however, is where the Open ODS is created based on a view and exposed to BW through HANA SDA. In this case, a virtual table is created and a select can be written to select data from this virtual table. Now let's look at the Open ODS view in a little bit more detail. So in my BW modeler perspective, I can see that I've got my Open ODS view, and if I look at the definition, see that it is based on a database table or view and from a HANA database. In my modeler perspective, let's just confirm the view itself, and I can see the create statement that it is actually a view. Then in my SQL console, I can now go and select data from my Open ODS view through my external HANA view on my composite provider. So it's again, select star from my composite provider where the info provider is the virtual open ODS view. If I execute it, I can see that it returns information in the same format as through any other object selected through my composite. There are several benefits to using open ODS views over an ADSO. First, an open ODS does not physically store data on the database. It can be based on a HANA view, ABAP CDS view, and so on. This in itself reduces data redundancy that comes from replicating and physically extracting data. If the customer is on S4, for example, we can create an ABAP CDS view and expose it to our application through HANA SDA. In this case, we don't need to extract data at all, and we have access to the latest actuals. Secondly, as alluded to in the first point, we can have access to real-time data. For example, COPA volumes and table ACDOC-A can be directly accessed and used in our planning applications. The combination of real-time information and no data redundancy reduces maintenance, so there's no more process chains to run and monitor, and open up more possibilities to create powerful planning applications. In the next lecture, we will be creating our info providers.